Hey guys, so today we're going to talk a little bit about comparing polynomial functions. We've seen already that you can represent a polynomial in 4 different ways, algebraically, numerically, graphically, and verbally. And I did sort of talk about odd degree polynomials and even degree polynomials, and that has to do with the highest exponent that you have. So an odd degree function, what I want to say, because we're going to talk about a little bit about the x-intercepts, it has, at least one x-intercept, which means it's going to cross that x-axis at least once. And then up to a maximum of n x-intercepts. And the n is the highest exponent. So if you have like an x cubed function, so where your highest exponent is 3, it's going to cross at least once, but it could cross up to 3 times, okay? So just be aware of that. What else? An even degree function is a little bit different because it can have, it can cross anywhere from 0 x-intercepts, because it might not cross at all, up to n x-intercepts. And if you've done anything with parabolas, you know this is true because sometimes our parabolas never hit the x-axis and it never crossed it. So this can happen. Let's see what else. There is local maximum and minimums on the graphs as well. So I'm just going to talk about that for a sec. If you have max and min, so if you have a graph that looks like this, this would be considered a local max because it comes up and then goes back down. So it's a local max. It's just a maximum in that small area. And then here would be a local minimum. And the same thing happens with the even degree polynomials. You might have one that looks like this. And in this case, you would have a local max. This would be a local max. And then here would be a local minimum. Okay. So be aware that also that these are not necessarily the maximum points of the graph, because over on this side, your y values actually get higher than your local max. Local max just refers to that one small area. A second thing we're going to talk about even and odd functions and the symmetry. It's a little bit different than our odd degree and even degree. In this case, it's an even or odd function. And there's a couple calculations we can do for that to show whether it's an even function or an odd function. And then that also tells us some things about the symmetry of our polynomial function. So we're going to do that next. Okay, so an even function has symmetry about the y-axis, which basically is, you would have seen this with parabolas, where this side over here is the same as this side. If you can basically fold it in half along that y-axis and get the same thing. So for an even function, it states that if you have, if you put a negative x into f of x, you will also get the same as the positive. Okay, for all x's in the domain. And that means that, yes, it's got that line of symmetry there. I'm going to show you an example in a second of that. So let's see. We've got a function x to the 4 minus x squared plus 2. So if you want to find out if this is even, you actually would put a negative x there, put negative x's where the x's are, and basically see if you would get the same thing pop up. So you're looking to make sure you get this pop up. So what happens when you have an even exponent, negatives will become positive. So this will become positive x to the 4. This x squared, x minus x times minus x gives us a positive x. So again, this one is x squared, and the 2 doesn't change. So because then you can say that the negative x is equal to f of x, which means we're going to have symmetry along that y-axis. Along the y-axis. Okay, so along that y-axis, you can basically fold it in half and you'd have the same thing. The odd function says that if we do f of negative x, what ends up happening is you get a negative of our original or whole original function. And it has symmetry about the origin. And it's rotational symmetry, so it's point symmetry. Point symmetry. And we'll do an example of that. I'll show you one. So let's say that f of x equals x cubed plus 3x. So you'll do the same thing. You'll put the negative x in plus 3 to the negative x. Now, when you're doing cubed root, or the cube of a negative, so a negative times a negative times a negative, it's going to be negative x cubed. And 3 times negative x is minus 3x. Now, if I were to factor that negative out, I would have x cubed plus 3x. So you can see this was the same as that, but now we have a negative sign in front of it. So f of negative x equals the negative f of x. So in this case, it is a odd function, and we have that symmetry about the origin. So one of these might look like that. So you notice that this side up to here it's symmetrical, like there, you can fold it. If neither the odd function or the even function, if you don't have any of the symmetry and neither one of them work out, then you would say that you don't have any symmetry about the origin, and you don't have any symmetry about the x or the y-axis, and then you can just say that they're not even. It's not an even function or an odd function. Sometimes that happens, but yeah, that's everything for today. I'll see you guys later. Bye.